Hello. Today we're going to talk about the lymphatic system, and this is in chapter 23 of our Martini textbook. My name is Dr. Gamo, and we're going to review the special function performed by this particular system. Okay. The lymphatic system, as you can see in this particular slide, is made up of the lymphatic vessels, the lymphatic organs, and of course what is found inside these vessels would be the lymph. Okay. And so lymph is essentially a product that came from the blood plasma. It's made up of the interstitial fluid, which is a fluid found in between the cells, and your lymphocytes, which are a type of white blood cells, which you have discussed in the lecture on the blood. And of course you have your macrophages. Macro means big, phages means cells that can eat other cells, particularly bacterial cells. Okay, and lymphatic vessels, these are found when you have blood vessels, right? Normally beside the blood vessel will be a lymphatic vessel, and the lymph flowing through these vessels will be filtered by the lymph nodes or lymph organs. And here is a very important slide. One must know that the primary lymphatic structures includes the thymus. The where the thymus found is behind the sternum. It's rightly in front and slightly above the heart. It's in the thoracic cavity, and the red bone marrow, of course, is found in the bone. And the secondary lymphatic structures or organs include the tonsils, your lymph nodes, which is found in the armpits, called axillary inguinal area, in the femoral triangle, and of course pelvic and lumbar split lymph nodes, and of course the largest lymphoid organ would actually be the spleen. If you recall, it is in the spleen where the red blood cells die, but aside from the fact that this is where the red blood cells will die, it is the spleen that is the primary and largest lymphatic or lymphoid organ. And then what we call MALT. What does MALT mean? Because associated lymphoid tissues, which can be found in many parts of the body, like the small intestine and the lungs. So here's just a very important slide. So when you have the time, I want you to go over this. So we have a lot of lymphatic vessels colored green. If you remember, the blood vessels were colored either red or blue. Blue means venous blood, which is rich in carbon dioxide. The arteries were colored red in the lecture on blood vessels, wherein it is carrying oxygenated blood, while the lymphatic vessels in this particular slide is colored green. Okay, and they are able to flow all throughout the body. And like here, you have the axillary lymph nodes in the armpit. You have cervical lymph nodes in the neck. You have your the tonsils, which are found at the back of your throat, and they either can have the pharyngeal tonsils and the palatine tonsils, which is found in the palate. Thymus gland, as I said, is in the sternum, behind the sternum. It's within the thoracic cavity. And of course, you have the MALT tissues in various organs like the digestive tract, small intestine, the lungs, and of course, even the appendix, in fact, is an example of a lymphoid organ or lymphoid structure. So we have here the lymphocyte, which, as I said, is part of blood produced in the red bone marrow. So what would be considered primary would be these two, thymus and the red bone marrow. So I don't have to read through this. For you to read this, it's very important. Produce, maintain, distribute lymphocytes, maintain normal blood volume, because it actually helps in the distribution of fluids, particularly the drainage of the interstitial fluid found between the cells, and of course alternate route for these substances such as hormones, nutrients, and particularly some waste products. So as we have said, with our primary and secondary lymphatic structures, we said that would include the thymus and the red bone marrow. If you remember on the lecture on the blood, your white blood cell has granulocytes and agranulocytes. The agranulocytes are made up of lymphocytes and monocytes, and under lymphocyte we have three types: T cells or T lymphocyte, B cells or B lymphocytes, and NK or what we call natural killer cells. And as we said, the secondary lymphatic structures, we include all the tonsils, all the lymph nodes and the spleen. Okay, and again, we talk about the important role that they play in defending us against any form of bacterial invasion or viral invasion. So maintenance of blood volume normal blood volume is very important. We recall that the normal blood volume is 6 liters of blood in the body. And again, also maintenance of the composition of the interstitial fluid. Again, what is the definition of interstitial fluid? It's a fluid between the cells. And again, you can see here the role played by this lymphatic system in the maintenance of the interstitial fluid as it is being drained into the lymphatic capillaries, which we will discuss in a short while. So here's a very nice diagram. I want you to study this because you can see here the red arteries, what you call the small arteries are called arterioles, and small veins are called venules. And as you can see, the movement of fluid, the fluid in the capillaries, it's actually in the capillaries where the exchange of fluid will occur because that's the smallest blood vessel. And apparently, so the words capillaries are there. The fluid inside will go into the space between the cells called the interstitial fluid, and from the space, these are the cells. The space between them is called the interstitial fluid space, which contains fluid, and the fluid is drained by the lymphatic capillaries that will go into the lymph. So if there's a problem in that movement of fluid, then you end up with edema or swelling, because you're now not able to remove or drain the fluid from the interstitial fluid. So that's a very important thing to remember and understand. So the other function, alternate route for hormones and nutrients like lipids. This is usually found in the small intestine, and waste products too. And we already showed you an example of the counterpart of the blood vessel capillaries or tissue capillaries, which happens to be the lymphatic capillaries. Now the lymphatic ducts are the largest ducts. You have one called the thoracic duct and the right lymphatic duct. And again, this is just a comparison. I want you to read and know the differences between the vascular or the blood vessel capillaries with the lymphatic capillaries. So lymphatic, the capillary larger, thinner walls, irregular outline. And another feature is they have the anchoring filaments. Okay. So this is how the lymph will flow. So the fluid in the interstitial fluid will end up going into the lymphatic capillaries. And as they pass to the lymph node, they will be filtered. The lymph will be filtered by the lymph nodes. So again, comparison between larger lymphatic vessels, veins, thinner wall, large lumens, and do not have tunics. Remember the tunics or the layers? In the veins, you have the tunica intima, media, and externa or adventitia in some books. Okay? Large lymphatic vessels have valves just like most veins. Remember, if you were to compare the arteries and the veins have valves. So as the large lymphatic vessels. So here, as we said, there's you can see here the green is representing the lymphatic vessels, the veins in blue, which carries carbon dioxide rich blood, and the arteries carrying oxygenated rich blood. Here is a valve being shown inside a lymphatic vessel in this particular slide. See here, artery, a vein, and lymphatic vessel giving you a cross section so you can actually see the lumen. The large lumen of the veins followed by the lymphatic vessels. Okay, again, the lymphatic valve found inside the lymphatic vessel, so they will regulate the flow of blood, or in this case, lymph in one direction. And as you can see here, large lymphatic vessels, pressure in the lymphatic is lower than compared to the vein. That's why you would expect the flow of fluid from the veins towards the lymphatic vessels, from high to low. Okay, and the valve prevent what? What's the key word there? Backflow. Okay. So there are either superficial deep lymphatics depending on the location, as you can see here. Some of them could be in deep areas, especially in the area where you drain skeletal muscles and tissues of the neck, limbs, and trunks, and particularly visceral organs. So there are 5 major lymphatic trunks: lumbar, remember the area of the lumbar spine, intestinal trunk, bronchomediastinal, subclavian, remember? And of course jugular trunks. So everything that's green represents a lymphatic vessel. As I have said, you have here the different trunks. It's being labeled in this particular slide. Now, the main lymphatic duct that is going to drain goes into the subclavian veins. So as you can see, all the lymph will eventually go back to the veins. In this particular case, the left subclavian vein for the thoracic duct. It is the main thoracic duct that drains most of the what? The lymph. Okay, so it drains lymph from the abdomen, both leg, left arm, torso, neck, head. As you can clearly see here, it's quite extensive. And while this will only be the one being drained by the right lymphatic duct. Okay? And this is also going to be able to drain into the subclavian vein on the right. See? So you can see here the left and the right subclavian vein, that's where the ducts would bring the lymph into. Okay? So it drains into the right subclavian vein, right lymphatic duct. Only a small portion is being drained there. See? Now, okay, so the idea therefore is that it doesn't form of recycling. You know, what came from the lymph, remember, it came from the blood and plasma. So what came from the blood goes back to the blood via the subclavian veins. So bear that in mind. And of course, the lymphocytes are the primary cells of the lymphatic system. As we said, you have different types of lymphocytes. These are the function, respond to invading bacteria and viruses, and even cancer cells. They can attack cancer cells. Okay, that's very important. Even foreign proteins and toxins. And it can travel by exiting the bloodstream and of course into the interstitial space, as we have seen a while ago. And again, re-enter the veins via the subclavian veins to the right lymphatic duct and the thoracic duct. So a review of the T cells and the B cells and the NK cells. So T for thymus dependent, B for bone marrow derived cells. So here are examples of T cells, as we said, originate in the bone marrow, but they will eventually go to the thymus to mature, okay, and become immunocompetent by the release of a hormone called thymosin from the thymus gland. And mature T cells leave the thymus and migrate to the red marrow and spleen. So these are examples, so be aware of these different types of T cells. Cytotoxic, helper, regulatory, and memory T cells. At the same time, this slide is very important. I want you to memorize what each of these special slides or cells do. Like cytotoxic, attack the foreign cells and viruses directly. They do not, I repeat, they do not produce the antibodies. They will actually attack the foreign cells. They have helper T cells, stimulate both T and B cells, and help the B cells produce antibodies. Regular T cells for immunoresponse, modulation, and of course, memory T cells, very important. On the other hand, the B cells of B lymphocytes came from plasma cells. They are the ones, they will eventually become the plasma cells that produce the antibodies. And another name for antibodies is what? Immunoglobulins. So as you can see, they are made of proteins. Memory B cells become activated in the same antigen pairs at the later date. Now, what about natural killer cells? The same thing, they attack foreign cells, which are the enemy, and attack normal cells that are infected with the virus. And even, very important too, cancer cells, okay? So here is a slide that will show you exactly what you need to know about the lymphocyte formation and immunity. As you can clearly see here, you can see here the different types of cells and how they are formed from the bone marrow, eventually some of them going to the thymus gland, particularly the T cells. And then as you can see here, the roles that they play. Always remember, the B cells are the one that produces the antibodies, right? So apparently as a summary, therefore, when we look at these cells, the T lymphocytes, so the white blood cells, as you recall, would be made up of two granulocytes. And what's the other one? The A, or agranulocytes. And apparently A means without granules in the cytoplasm. And you have the lymphocytes and the monocyte. The monocyte is the big giant macrophage. Lymphocytes, you have T, B, and NK. The T cell or T lymphocyte is for what? Cell-mediated immunity. On the other hand, the B cell is being converted into the plasma cell, and the plasma cell releases antibodies, or what we call immunoglobulins. This is the B cell that becomes a plasma cell that releases antibodies, and of course for immunosurveillance. And they will also attack foreign cells, or the NK or natural killer cells. So again, as you can clearly see, therefore, this slide is very, very important. Okay. Now, as we have said, therefore, based on what you see here, you need to know the slide. Now, cell-mediated, I mentioned that. They self-directly attach to the pathogen or the disease-causing organism. Antibody-mediated immunity is also known as humoral. And how do you spell humoral? Humoral immunity is spelled H-U-M-O-R-A-L. And as you can see, it is very important. Pathogen attack by the antibodies produced by the B cells. So again, sequence of events, immune response, you have all these cells involved. Okay, this is very important. Macrophages or phagocytize means to eat a foreign cell. It's a very important role played by these white blood cells. The macrophage will present antigen to specific T cells, which we have mentioned. There are many forms of T cells, antigen presentation, and the T cells begin to divide, produce all of these types of T cells that we have mentioned a while ago. Okay. So again, the next few slides get to see what each of these cells will do. Cytotoxic T cell kill the agent, that's bacteria. Directly T cells activate the B cells. So each one of them have a role to play. So I want you to know them. Okay. So this is the ratio of T cell to B cells in the blood 8:1, spleen 1:1, bone marrow 1:3. Most of them will live between 4 to 20 years. Okay. Now lymphocyte production, it's called lymphopoiesis. As we can see here, we don't have to memorize the details here. They're produced in the bone marrow, but the T cells migrate to the thymus gland. T for thymus, T for T cells. And once they are exposed to the thymosin, they mature. Okay? And then, of course, the matured cell will go back to reside in the bone marrow and the spleen and other lymphatic structures. Now, the lymphoid stem cells will, some of them will stay in the bone marrow, B cells and NK cells. And as I said, it is the B cell that produces the antibody. That's why it's called humoral immunity, where it's antibody mediated. And as we said, what's the fourth role of NK cells? Immunosurveillance. Very, very important. Okay. So again, we don't have to go into details here. This is just what would be found in lymphatic node or nodule. You have all these lymphocytes plus a germinal center which contains the lymphocytes. Some of these lymphatic tissues are either in the pharyngeal tonsils, otherwise known as your adenoids, your palatine tonsils, your lingual. Lingual means what? Tongue. Okay. And this is what it looks like. So these are types of nodules, MALT, and the tonsils we just mentioned. And in the small intestine and appendix, you have your Peyer's patches. So these tonsils, when they are exposed and you have an infection, they become inflamed, and it can be cause of tonsillitis. And again, be aware of what happens. Okay. So this is what it looks like under the microscope. The presence of your Peyer's patches in the small intestine. And again, the lymph nodes, the thymus gland and the spleen, as we said, they could be found surrounded by capsules. Okay? And again, the lymph node. So if it's found in the axilla, it's called the axillary lymph node. Inguinal lymph nodes in the inguinal region or femoral region. And they're found everywhere. The problem with this lymph node, they're supposed to filter the lymph for any infection or bacteria, but it's also where the cancer cells could spread. That's why a breast cancer patient may end up with metastasis or spread of the cancer into the axillary lymph node, which is not a good sign. Okay? It's a very poor prognosis or outcome. It means there's severe spread of cancer cells. So we're not going to talk about the lymph nodes. Consists of the hilum where the blood vessels enter and leave the lymph node. You have a capsule. You have a outer cortex, which has the germinal center with the B cells. And then of course you have also the medulla, which contains the B cells and macrophages. So this is what it looks like. So you have efferent going out, afferent vessel, you have the arteries and veins. And as I said, there are different locations of these nodes. Cervical, axillary, popliteal means behind the knee. Inguinal, as we said, in the femoral area, in the hip area. Thoracic lymph nodes are also found. And again, they are important because first they protect you against infection, they filter the lymph, and at the same time, unfortunately, it's also where they become involved in spread of cancer to these lymph nodes, right? So when you have cancer of this area of the head and neck, these lymph nodes can become enlarged because of the spread of cancer cells there, okay? Same thing here, the axillary lymph nodes, breast cancer can spread there. Very, very important. That's why when women are palpating their breast, we also recommend that they palpate the axillary area because the lymph nodes could be enlarged. Inguinal lymph nodes in the femoral triangle. Okay. And then of course, if it's abdominal thoracic region, we definitely have lymph nodes also in those areas of the body. So inguinal lymph nodes, see? Apparently, this is the male genitalia, the penis with the scrotal sac and the testes there. You can see here that whenever you have an infection in the foot or leg, in order to prevent the spread of the bacteria, these lymph nodes can filter and prevent, and that's why oftentimes they can become inflamed and enlarged. Now, in the area of the GI tract or the gastrointestinal or digestive tract, you can also have all these mesenteric lymph nodes, everywhere. Okay. And as we said, the thymus is found behind the sternum, behind the membrane. And unfortunately, it decreases in size after puberty, and that could probably explain the reason why, as we get older, we get easier, we get infected with different kinds of viruses and bacteria, and the recovery and healing recovery phase is longer because of the decrease in the size of the thymus gland, which develops atrophy. Atrophy means decrease in size. It has the left and right lobes. It's a cortex and medulla too. So there it is. So right above the heart, or in front and above the heart, thymus gland. Do not confuse the thymus gland with the thyroid. Thyroid is in the neck, the thymus here is in the chest, in the thoracic cavity. So this is what the thymus looks like. So this is what it is inside the microscopic view. The spleen, as I said, what's the key word? Largest lymphatic organ. As we know, it's where the red blood cells die after 120 days. So the spleen is in the left upper quadrant, while the liver is on the right upper quadrant. The spleen is on the opposite side. And you have a diaphragmatic and visceral surface. Two blood vessels that enter the spleen will be the splenic artery. What will leave the spleen will be the splenic vein. So obviously the artery carries oxygenated blood, while the vein carries deoxygenated or blood-rich in carbon dioxide. Okay? So this is what the spleen looks like. If you rupture the spleen, there could be massive bleeding because it is a highly vascular structure. So you have a red pulp and white pulp. Red pulp because of the presence of the red blood cells, so it's red. The white pulp forms lymphoid nodules. So that's what it is, a capsule, the red pulp, and of course splenic nodule, and the white pulp shown here. As we age, T cells become less responsive to antigens. So this is how come elderly people are more prone to infection. These are the reasons, so make sure you're aware of these. Number of helper T cells decline, B cells they become less responsive. As we age, we have increased susceptibility to infection. That's why anybody who is 70 or 80 years old can easily die of a pneumonia, which is a lung infection. And as I said, there is atrophy of the thymus gland. Okay, that's it.